Hello, calculus students, general seekers of truth. We continue our journey in understanding particle motion as we discuss what's next here, which is figuring out the speed. And I am referring to some stuff that we did in the previous videos just to speed things up a little bit. No pun intended. All right, so we want to figure out here, when is the particle speed increasing? And from our previous discussion, we know that speed increases whenever velocity and acceleration are in the same direction. Okay, whenever velocity and acceleration are in the same direction. Okay, we already figured out the velocity. Just a quick recap, the velocity of this function of the particle is 3t squared minus 18t plus 17, and we already made the sign chart of the velocity graph. We know that the velocity is negative from negative infinity to 1.172, positive, whoops, I got this backwards. This is the other way around. It's positive from negative infinity to 1.172, negative from 1.172 to 4.286, or 826, I think. 4.826, and then positive after that. So we already figured all the information from the previous problem regarding the velocity. Look at the other videos if you need to. Now we need to find the acceleration. So the acceleration is the derivative of the velocity, which is 6t minus 18. So that's a lot easier to solve. Set the acceleration equal to 0. And we get that t is equal to 3. So looking at the sign chart for the acceleration graph, or the acceleration function, whenever t is small, less than 3, this is negative, and whenever t is large or bigger than 3, this is positive. So let's look at where is it that the velocity and the acceleration are in the same direction. So let's look at all the way from negative infinity. So and I'm going to try to just kind of like put both of these graphs together onto the same scale. We can still make sense of it as is, but it's a little easier, I think, to put everything onto the same graph. So we're going to combine these two sign charts in a way. So we're going to put, let's see, we're going to put all these numbers on there. 1.172, and then 3, and then 4.826. Okay. So the velocity is going to be positive. The velocity is going to be positive here and here. And the acceleration is going to be positive from 3 onwards. Okay. So the section where the velocity and the acceleration are both positive would be this block right here. So really from 4.826 onwards, the velocity and acceleration are both positive. All right. Now let's consider where the velocity and the acceleration are both negative. So what we know before, the acceleration is going to be negative I'm sorry, the velocity is going to be negative between 1.173 and 4.826, and the acceleration is going to be negative from negative, let's see, get some good colors here, anything to the left of 3. So the acceleration is negative that entire section. So if you look at where they both line up, let me use a different color here. I don't know what colors make any sense anymore, but it's really from 1.172 to 3 from this section here, right? That's where the blue part and the green part overlap. So during that area, during that section, the velocity is negative and the acceleration is also negative. So we have this block here from 1.172 to 3, and then from 4.826 onwards is where the speed increases on the interval 1.172 to 3, and then union with 4.826 onwards to positive infinity. So during those moments is exactly when the velocity and the acceleration are both in the same direction. Okay, let me just write this stuff better. This is ridiculous handwriting right now. All right, so let's try this. 1.172 to 3, and from 4.826 to positive infinity. And let's go back and let's look at this graph here just to get a better sense of exactly what's going on. So we want it to be both increasing and concave up. So increasing, and so when 1, 2, 3, this is the inflection point right here. Okay, so this is the inflection point. That point right there, and we want to know where is it exactly that the curve is both increasing, or the position function is both increasing and concave up. Well, right here, this section of the graph, or decreasing and concave down. Okay, or decreasing and concave down. So that's that section. So during those two intervals, the speed of the function is increasing because the velocity is negative and the acceleration is negative, or the velocity is positive and the acceleration is positive. Okay, so I'm looking at the position time graph here. So that's why this point right here is the point of inflection at t equals 3. Okay, so this is a kind of a tricky concept once we actually use a function in an example here, but if we go back to the basic understandings of this, it is possible to answer this intelligently. Okay, so now we have 2 final questions remaining, and I have to clarify this was a typo in the notes that I may have handed out to you. I didn't give you this interval. We need to find the particle's maximum speed on this interval. Okay. Well, and remember that speed is, well, the absolute value of the velocity. Okay, so it's not just the velocity, it's the absolute value of the velocity. We already know, again, that the velocity function is 3t squared minus 18t plus 17. And when we're looking for the speed, we have to consider where the velocity is at a maximum, positive, and where the velocity is at a minimum, negative. So let's just let's figure out where the extremas of the velocity functions are. So let's take the derivative of the velocity function. This gives us 6t minus 18. Set this equal to 0. So we get that, again, t is equal to 3. Right, so this is v prime, and this is a little bit redundant, so I'm going kind of fast. Right, so let's get this a little bit better here. V prime. So we have this 3 right here. V prime is going to be negative here and positive here. So here we have a min. Right? So let's make a table here of the t values and of our v of t. Okay. So there are some candidates for maximum and minimum. They could occur at 0, it could occur at 3, or it could occur at 5. Basically, the local extrema compared to the local extrema and the endpoints here are the possible places where minimum and maximum can occur. So when t is equal to 0, v of t would be equal to 17. When t is equal to 3, we, I think, did this earlier already. This is going to be negative 10. And when t is equal to 5, I haven't done this yet, so let's work out this. 3 times 25 minus 18 times 5 plus 17. So 75 minus 90 plus 17, that's 15 plus 17, which is equal, that's, I'm sorry, negative 15 plus 17, so that's equal to 2. Okay. So looking at the three numbers here, we have velocity, okay, but we want to know speed. So speed is the absolute value of velocity. So we just take the absolute value of these numbers. That's 17, 10, and 2. Okay. And I want to point out here that in this case, it happens that the velocity, the maximum velocity, and the maximum speed are the same. If this number down here at t equals 3 had been a gigantic negative number, then once we figure out its speed, that would be the maximum. So we can answer this question and say that the maximum velocity, the maximum speed on this interval is 17 meters per second. And then so again, I want to stress that we're looking for maximum speed here, not necessarily maximum velocity. And we have one nice, simple example to close this out. What is the particle's acceleration at 6 seconds? Well, we already know that v prime of t, which is really the acceleration function, is equal to negative, what was it? From up here, we have positive 6t minus 18. So positive 6t minus 18. So the acceleration at 6 seconds is equal to 6 times 6 minus 18, 36 minus 18, which is exactly 18 as well. Okay. And the units here are critically important. Acceleration is the change in velocity, so it is meters per second, or we can say meters per second squared. So there you have it. A lot of complexity in this, and a lot of just, you know, things that make you think about these problems and what f prime, f double prime actually mean. It's easy to get tripped up, but keep working hard. As always, ask for help if you need it. Thank you for watching, and have a wonderful day.